Hello, in this video I am going to prove the converse of Ceva's theorem and use this theorem to prove in a unified way the concurrency of medians, angle bisectors, and altitudes of any triangle. So first let us read the converse of Ceva's theorem to understand what the content is. So let x, y, and z be points on the sides BC and CA and AB of triangle ABC respectively. So I have a point x on side BC, I have a point y on side AC, and I have a point z on side AB such that the ratio of the length of BX over the length of XC, this ratio, multiplied by this ratio of Cy over Ya, multiplied by the ratio of Az over Zb is equal to 1. Then the Cevian lines Ax, By, and Cz are concurrent. Okay? So this is the converse of Ceva's theorem. So if you remember, in the Ceva's theorem, we had three Cevian lines which we already know they are concurrent, and then we proved that this relation holds. Now we want to prove the converse. Okay, so how should we prove the converse? The proof is proof by contradiction. Of course, I would say that let us draw two of these Cevian lines. Let me draw By, yes, and also CZ. They will intersect at a point, and I call that point point O. My claim is that the Cevian line AX will also pass through the point O if this relation holds. Okay, let us assume that this is not the case. What does it mean? It means that, for example, when I take A and connect it to O, this continuation, instead of passing from point X, passes to another point on the segment BC, call it X prime. Of course, in reality, this does not happen. So you have to imagine that if I take A and connect it to O, which is the intersection point between the Cevian lines BY and CZ, and continue it will intersect BC at a point X prime, which is not X, and I want to show, no, this cannot happen, and we have a contradiction. So my assumption here is that the point X is not equal to X prime, and I want to show you that this is not going to happen. Okay, now consider three Cevian lines now. One of them BY, the other one is CZ, and the other one is this dotted line that I have actually drawn here. So we know that these Cevian lines are concurrent at point O. So using the Ceva's theorem itself, I can write the ratio of Bx prime over x prime z, or x prime c multiplied by cy over ya multiplied by az over zb is equal to 1. Okay, this is using the Ceva's theorem itself. Now, according to my assumption, this relation also holds. So this means bx over xc multiplied by cy over ya multiplied by az zb is also 1. So what does it mean? It means that this quantity and that quantity are equal. Both are equal to 1. But if you see that these are exactly the same, so this means that the first bx prime over x prime c is equal to the first fraction of the second one, bx over xc. But then we can combine the numerator to the denominator. So if you have watched the previous videos, we know that if I have a over b equals to, say, c over d, then if I want to, I can write the numerators as they are, and I can write a plus b in the denominator of the first one, and I can write c plus d in the denominator of the second one. Whenever this holds, I can also be sure that this also holds. So I will apply this rule here. So this means that I copy and paste the numerators, but then I will add the numerator of each one to its corresponding denominator. The same happens here. And now what happens, if I ask you what is bx prime plus x prime c, bx prime is here, x prime c is here, so if I add them up, it becomes bc, so the numerator is bx prime, and the denominator is bc. On the right hand side, the numerator is bx, but the denominator becomes again bc, yes, because bx plus xc is also bc. Now I have two fractions that are equal, but these two fractions have the same denominator, so it means that the numerators should be equal as well. So bx prime is bx. So I know that x and x prime both lie on the line segment BC, and the distance from x prime to b is exactly equal to the distance from x to b. This cannot happen unless these 2 points are the same. And this is my contradiction, because on the one hand, I have assumed that x is not equal to x prime, and on the other hand, using Ceva's theorem itself, I have to admit that x is equals to x prime as well, so and that's my contradiction. So this means that when I take this one and connect it to O, it has to pass through x. It cannot pass through other points. So it means that if this holds, then these three Cevian lines are concurrent. Okay, so now let us see how this will be helpful if I want to prove the concurrency of medians, angle bisectors, and altitudes in a unified way. This makes the proof extremely simple and straightforward. So let us consider the case for medians. So these Cevian lines now are medians. So it means that x is the midpoint of the line segment BC, y is the midpoint of the line segment AC, and z is the midpoint of the line segment AB. Of course, in reality, we know that the medians are concurrent, but this is still something which we don't know. Okay, we want to prove it. But instead of proving it using the methods that I have shown in my previous videos, I can use the converse of the Ceva's theorem. So what I need to convince myself of, I have to convince myself that the ratio bx over xc multiplied by cy over ya multiplied by az over zb is equal to 1. But this is extremely simple, yes, because x is in the middle, so this means the length bx and xc are the same. So this fraction is equal to 1. For the same reason, the second fraction is also equal to 1 because y is in the middle of line segment AC. And the third one is for the same reason 1, and when I multiply them, it becomes 1. So according to the Ceva's converse theorem, we actually realize that the medians are concurrent. Okay? For angle bisectors, I have to use a theorem. If you watch my previous videos, there is a theorem called angle bisector theorem. Okay, so again, for this case, I am assuming that AX is the angle bisector of the angle A, BY is the angle bisector of the angle B, and CZ is the angle bisector of the angle C. And of course, in reality, we know that they are concurrent, but that is something we don't know at the moment. We want to prove it. Okay, but we know that if AX is the angle bisector, we proved in one of our previous videos that the ratio of bx over xc is equal to this side over that side, the ratio of side AB over AC. And similarly, we can write cy over ya equals to bc over AB. Yes, so the ratio of cy over ya is equal to bc over ab. And finally, az over zb is equal to ac over bc. Now, if I multiply all sides together, side by side, so the left-hand side, which is bx over xc, multiplied by cy over ya, multiplied by az over zb, becomes equal to ab over ac, multiplied by bc over ab, multiplied by ac over bc. But then you can see that this BC and that BC are simplified, AB and AB are cancelled, AC and AC are cancelled, and I get again 1. And again, using the Ceva's converse theorem, we realize the angle bisectors also has to be concurrent. Okay, now let us consider the last case. So let me open up a little bit of space here. So let me draw this line. Okay, so in this case, what we want to do, I want to write bx over xc in this form. So I concentrate on this right-angled triangle here. And then I would say that this length bx is the hypotenuse AB multiplied by the cosine of this angle, which is cosine of the angle B. Okay, and I will do the same thing for the other one. So this becomes simply AB multiplied by cosine of B divided by, for XC, I will concentrate on this right angle triangle now. So XC is the hypotenuse AC times the cosine of the angle between these two, which is angle C. So this becomes simply AC times cosine C. And then I will do the same thing for the other two fractions. So I would say that CY over YA is equal to. Now I concentrate, for CY, I concentrate on this right angle triangle. And then I would say that CY is the hypotenuse BC multiplied by the cosine of angle C. This becomes BC cosine C divided by, for YA, I concentrate on this right angle triangle, and I would say that YA is the hypotenuse AB multiplied by the cosine of A. This becomes AB multiplied by cosine of A. And finally, I would write AZ over ZB is equal to, for AZ, I concentrate on this right angle triangle, and I would write AZ is equal to the hypotenuse AC multiplied by cosine of A. So it becomes AC multiplied by cosine of A. And finally, for ZB, as is clear, I will actually concentrate on this for ZB. So ZB is the hypotenuse BC multiplied by the cosine of B. So it becomes BC multiplied by cosine of B. And now I want to multiply them side by side. So on the left-hand side, when I multiply, I will get exactly bx over xc multiplied by cy over ya multiplied by az over zb. And on the right-hand side, something interesting happens, as you can guess. You see, AB appears here in the numerator, but AB here appears in the denominator, so they are cancelled. Cosine B appears in the numerator here, but cosine B appears in the denominator, so they are also cancelled. Cosine C cancels this cosine C. AC cancels this AC. And then this BC in the numerator cancels this BC in the denominator. And finally, this cosine A in the denominator cancels this cosine A in the numerator. And then again, I get 1. So this means that again, using the converse of Ceva's theorem, because this product is equal to 1, it means that these Cevian lines, which in this case are altitudes, are concurrent. Okay, so I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.